right? Compound equality. Compound equality actually, it means they made a several inequality, a multi inequality. Most of the time have 3 different spot, something like here, say A less than B less than C, all right? Or let's say A less than B and B less than C. So they describe like this way. They put them together, say B greater than A and at the same time B less than C, right? They describe it together would be like this. Sometimes just like they made of actually inequality, but they have multi-inequality. They combine together in one expression as well, right? But they didn't change the properties, all right? They didn't change the properties. The most important things here is something like say A, we didn't write like this way, okay? Something like this one, we didn't write like this way. We say, okay, like here, B is the common part here, right? B is the common part. So you can write it continuously like here, A less than B less than C, right? Right. But we didn't write, if they are in this situation, this B is common part, you can write directly like this way. Sometimes have this situation, A less than B, C less than B. They cannot write into continuously, right? Yes, B is the common part right here. But they cannot write it into, say, B, yeah, B greater than A. But they cannot say like this, right? This one is, we cannot write like this, right? We cannot write like this. Is it correct? All right, we cannot write like this, right? Because something like I say A less than B, B less, C less than B. When you're graphing here, you can notice what's going on here. Here is, suppose here is positive infinity, here is negative infinity, here is B. So any number less than B is this part, right? A less than B. So A possibly in this area, suppose here. And C also less than B, also some data length here. They may be greater than A, they may be less than C, or maybe they exactly than A, right? They don't know. So you cannot write like this. But for this situation, that's the situation. Okay. Suppose B is here. The positive infinity, negative infinity, positive infinity, here is negative infinity. A less than B. A is this part. A in this area. A somewhere is here. All right. So A less than B, right? And B less than C. Yes. So B should be in this area. So you can continuously write like this. They can combine, just like they can combine together like this. But this part cannot write like this. And this part, these two can write like this. They are continuously, just like if their equation is the same, if they are alligator mouse at the same direction, they can write like this. All right. All right. This is the first thing. When you combine 1 and 2 inequality into one expression, make sure they are in the same direction, in the same way, same sequence. Right. That's very critical. Second one, the property of them is not changing. Right. So we earlier do these kinds of things is when we say left side and right side, when they plus the same number, they don't changing. Here is the same. When 3 side, we call right now we call left side, middle side, and right side. All right, we call left, middle, and right. And both sides plus a number, All right, we say it's D, okay? Every section should be do exactly the same, all right? All are plus the same D, all right? Left, middle, and right, both minus all of them, three sections, three minus the same number. This alligator mouse was not changing. The alligator mouse right here is not changing, right? Okay. Both of them add, three of them, here we say three of them add or minus the same number. The alligator mouse was not changing. This property is exactly the same like the inequality. All right. Second, three sides times a positive number. Say E, okay, we say E. E is a positive number. They are still the same. The alligator mouse was not changing. So if I time E, E is a positive number, right? The alligator mouse was not changing. If they are greater, it's a positive number. If E is a negative number, the three part time a negative number, their alligator mouse need to change into different directions. So they will be changed to their opposite. All right. So this is exactly the same as the equation. Okay. So keep this in mind. This is the property exactly the same to the inequality part in the only left and right part. Okay, let's give some examples here. Let's go to some examples. All right, let's see some example here. Compound. You can see this is compound inequality. Okay, so they use the property actually exactly the same to the equality. So what do we need to do? We need to find the x, right? What's happened to the x? You can see most of these kinds of compound equality, the x actually in the middle of this part, So what do we need to do? We need to change, do some proper transformation, make the middle part become x, right? All right, so this example first. Okay, so both three sides we call left, middle, and right. Right now we call three part, left, middle, and right. All of them add three. So with three of this part is do the same exactly changing, right? So the left, the middle is equal 2x, the right equal 8, the left equal positive 2. All right. So right now, for three sides, three parts, divided 2. The section, you do the same. So since they are positive number, the alligator mouse was not changing, keep the same, right? The middle left is x, the right equal 4, the left equal 1. The alligator mouse was not changing. So when we do the graphing, so we still do the same. So it's negative 1, 2, 3, 4. Here's 1, here's 4. Okay, so they are in between. Less than 4 is this part, right? Greater than 1 is this part. They are not including this two end, so only this area. So actually, this part is this area. For this part is this area. So we find their overlap area, right? This overlap area actually is from 1 to 4. So when we do the notations, 1 is end, right? Left is end, right is 4, right? And use the parentheses. This means not including. They are not have equal here, so not including. So we use the parentheses. Mhm. That's correct. Good. Okay, let's move second example here. All right, so we'll do the same. Left, middle, and right, right? But three sides minus 4 first. Okay, so it became -1 less than equal 1, right? Okay, so three sides times the same number, 2/3, they are reciprocal. This time 2/3. Okay, so this is a positive number. This alligator mass was not changing. So middle left is x. Here is 2/3. What about left part? -2/3. So that's it, this one, right? So when we do graphing, negative infinity, positive infinity, 0. Here is 3/2 is close to 1, right? Negative, this is -2/3, right? So it's this part in between here. They are filled, right? They are including the dot. So it's this part. So when we do the include notations is, we do what? So here is 2/3. Here is -2/3. This is comma in between, right? So use the bracket. This is including, this is including. All right. So we didn't do any additional, right? We do the same thing as earlier learning in equality part. Only is changing is the 3 sections. All right. Let's see this one. This is the third example, right? So firstly, we -1 first, -1. So 3 part, left, middle, and right. They do the same transform, all right? The middle and right. They do the same transform. You cannot do the different. Anyway, at the same step, okay? So the middle left is 3x. Here is 6. Here is -3. 3 parts, divide 3 at least. You can see the same step, do the same thing, right? All right. So when you're graphing, negative infinity, positive infinity, 0, 1, 2, -1, in between these two, right? They are not filled because they are not equal here. So in between here is 2, here is -1. Use the bracket, right? Oh no, use the parentheses. They are not including. They have not filled, right? So 3 examples where explained how we get a solution when in the compound inequality. All right, let's see more examples. Try to make it more clear. So right now, earlier one is a pretty easy one. Some of compound inequality like this one actually a little bit challenging. So left part actually is from my earlier classes for the summer program. Actually easy one. I think you guys can do this one. This is not compound, right? This is only one. This is only one. But this one go higher level because of here have the higher degree. We'll talk this a little bit later. Let's see the example in this part. Okay, so what do we need to do here? Firstly, we plus 6 as the middle, right, and left. Right? So became 3p less than -9 greater than -30. So 3 sides divide 3. Oh, sorry. So no change alligator mouth, right? So p less than -3, -10, right? So if you get -10, -3, both parentheses. So -3 and -10. -10 is right here. -3 is right here. So in between. No field, no field, no field. All right. Okay. Let's see more examples. Let's see more examples. Try to make it more a little bit a better understanding. So like this one, 14. Next one is not right together, right? So what do we do like this situation? Actually, this one is like this. So this one actually made of 2, right? Right? Okay, so let's see here. Actually, they made of this part and this part. They have 2 of the equations. All right. So you can see what do you need to do? You need to do it separately. Okay, so this one do it separately. So you can do this equation first, this part equation. So both sides, these are 2 sides, right? Left and right part. Both sides plus 1. So became -10a less than 0. So both sides divide -10 a greater than 0. This is the first part. For the second part, so 3a, both sides -10, less than equal than -15. Both sides divide 3, right? Less than -5. So you can see a greater than 0 or a less than -. So they have 2 different. Let's say this is all, not n. Okay, all means both sides. Here is means what? A greater than 0 actually is this part. This part. A less than -5 is this part. But they have contains the equation. So here part is need to be filled. So it's -infinity to -5. And we use this kind of signal called U, right? This is n. And here is 0, positive infinity. Okay, so that's this situation.
How to spell ice cream?
All right, why you cannot interrupt daddy? You separate. Okay. All right, let's move on. Second, this one, these examples. All right, here is all. So it means they have 2 different inequality, right? You need 2 of them to do 2 equations to find answers. Right? See the 15 part. This part first, and then see this part. All right, so let's go step. So here is both sides -7 and in 7n. Let me rewrite it here. Let's go small. Let me zoom in a little bit. Can I zoom in a little bit? Make our see black clear. Sounds good. Make a little better. Okay. All right. See this one. So first we -7n first. -7n. -2. Right. So left here is 0. Here is 0. Right. So here it became -4 and less than -4. Both sides divide -4. So n greater than 1. Right. So because of -4 is a negative number, so this one need to change alligator mouse to the different direction. So you got first is n greater than 1. See the second part. So both sides -3n, both sides +4. So here became 0, here became 0, here became 0 as well, right? So it became 5n less than equal than 0. So n less than equal 0 divided 5, right? So you can see here is all, we put all in middle. So it means n greater than 1 or n less than 0. We're graphing here. 0, positive infinity, there's negative infinity. Firstly, 1 greater than 1 is right this part. Less than or equal 0 is this part, including this field, make this field. So we write it negative infinity to 0 is bracket, right? And 1 positive infinity. Okay, sounds good. All right, let's see some more information. Compound equality. So compound equality sometimes just left, middle, and right. Here, compound equality means they have two different information. Okay, two different inequality to make the compound inequality. Let's see 16. So here is actually very similar, right? Very similar. Very similar kinds of situation. Right? See 16 here. All right. So that's two parts, 1 and 2, right? So all. So we do these kinds of equation just like earlier. What are we doing? How to find the solution of them? Both side minus 6r here. Make this 6r disappear first, and plus 5. Make this disappear. Right. So the left is became 2r in the left part, right? The right part left is 4. 5 minus 1. So both sides divide 2. What about right part? What about this? Both sides minus 3r. Make this disappear. Minus 4, make this disappear. Right? So both sides at the same time do the same thing. Minus 4, minus 4, minus 3r, minus 3r. So left part is r. Less than equal negative 7. Right? So here's r greater equal than 2 or r less than negative 7. Right? Okay. So this example is relatively easy for you guys, I believe. All right, let's see 17 here. 17 here. So you guys can do this progress as well, all right? Same thing. So all here separate. Firstly, we need to find the solution of here for, I'm sorry. Okay. Firstly, we see this left part first. So plus 7x, right? Make this disappear. 7x plus 7x minus plus 5. So actually this part disappear and this part disappear. Actually this part disappear as well. So became 12x greater equal than 0, right? All right, so you can got x greater than 0. What about the right part? Minus x here, right? So make this disappear. And minus 5, make this disappear. So for this inequality, the left part became what? 2x less than equals negative 6. Both sides divided 2. So you got x greater than 0 or x less than negative 3. Right? So 1, 2, 3. -1, -2, -3. 1 less than or equal -3 actually is this part. Make this field because of here, right? X greater than 0 is here. It's this part. So you can write a notation way is -infinity to -3 and 0 to positive infinity. So this is use the bracket. I have to change, right? So here is not parenthesis, it's right bracket. They are equal here, equal here. So you need to change it to bracket. All right, let's see one more question, one more examples. I think the right part example is close to what we're learning here. Let me do a little bit complicated situation. Let's see the example in the left part here. Give you a first kinds of brief of the harder part. All right, let's see these examples. This is inequality. This inequality actually in our homework often do this kinds of part, right? Already, we have to do this part already. So let's do one more time. I thought some people just joined a little bit late. Enoch, I think Enoch is Enoch Chen. So if you late, I have some video here. So in case I will send out a little bit late, in case you missed something. So let's see this equation, inequality. So firstly, we try to get rid of the parentheses in here, right? So we need to distribute it inside first. How to distribute inside? All right, so here is plus 2x, right? I think we do this before already, right? So here is gone. All right, so here is 6x, here is 2x. So minus 2x, make this disappear, right? Both sides at the minus 2x at the same time, right? Both sides plus 5. So make this disappear. So the left up here is 4x. What about this part? 5. Both sides divided 4. Both sides divided 4. This is positive number, right? Positive number. So it's okay for them. You don't need to change the alligator mouth, right? All right. So this is the first one. See the second one. Actually, right now it's go harder part, very harder part. Maybe sometimes you feel harder actually, but not so hard. All right. So first part, let me see. I'm sorry, I should go this one. So first thing we needed to get rid of these parentheses, right? So we need distribute inside. So right side became like this. Left part we just copy down. Don't change it, right? Okay. So both sides actually try to minus x squared, minus x squared. So this is disappeared, right? Disappeared, again 0. Both sides plus 10x, both sides plus 10x. So this one disappeared, make it more simplified. Both sides plus 10, plus 10. So make this disappeared. So the left part only left is 16x. What about right part? Okay. After this kinds of transformation, after this kinds of simplified, combine like terms, what we got is very simplified version, kinds of inequality, right? So both sides divide 16. 16 is a positive number. We don't change anything. So we just needed to copy down, right? So you can follow these steps. Right? I believe we have a lot of talk, a lot of kinds of similar kinds of things, but today we didn't talk about equation with the absolute value. Let me quickly go one or two of them, right? Right now we talked about compound equality actually is left, middle, and right. That would be easy for you guys, should be. Do the same transformation as inequality. But when the kinds of inequality contain absolute value, or some of them have contained denominator, what can we do? Let's talk about absolute value first. Earlier we talked about x, this one, right? In equation, suppose here x is a positive number. So when you find this equation, you often find is x have two solutions. One is positive a, one can be negative a, right? You can get two solutions. And just a quick example, say absolute x equal 5, so x can be 5 or negative 5. This is super easy to understand, right? Because so absolute 5 equal 5, absolute negative 5 also equal 5. So if someone asks you, say absolute x equal a is a positive number, yes, a has two solutions. So if let's say f is greater than 0, what are solutions? What are solutions there? How you get this solution? So we first need to get rid of this one, right? How we get this one? We need to judge. We suppose say x greater than 0. This is first requirement. So if they are greater than 0, so x greater than 0. Did you see this one? This is looks like combine these two, so x greater than 0. If x less than 0, when x less than 0, when you get rid of this absolute value, you need to what? You can negative x greater than 0, right? So you can change here is x less than 0. This part, both sides divided -1, right? So x also less than 0. So you got x less than 0. So you can see x greater than 0 or x less than 0. But x not equal 0, right? That's the solution. So only x at 0 situation, this absolute value will be equal 0. The rest, whatever numbers except 0, their absolute value will be greater than 0. So you have two situations. You can see when you need to judge, you need to prejudge. So propose inside this parenthesis one should be a positive number. Inside this parenthesis absolute value one, or it's a negative number. It's a positive number or negative number. All right. So you can see this one. Okay. So this one is easy for you guys to quickly go this step. So let's see these examples. If the x, absolute x less than 1. All right. Right now we're going to give you a quick hint. X should be, we get rid of out of this one. All right. Should be less than 1 and greater than -1. How is coming? Where this come from? I give you absolute value first. Something like this one can understand like this way. This is 0. We say x minus 0. Absolute value less than 1. What this means? X minus 0. Suppose one point is x is 0. The other point is x. X minus 0 means the distance between these two, right? The distance between these 2 points should be at absolute. It means any point, the distance to the 0 should be less than 1. So any distance, you can find 1. So here is, suppose here is 1 and 2. Here is -1. Here's -2. So find the point, the distance from the point to the 0 less than 1. So only distance actually is between these two, right? -1 to 1. -1 to 1. So any dot between -1 to 1, the distance to the 0 will be less than 1, right? Can you guys understand this way? That's this come from. This come from. Actually, you can do second methods. This is first way based on the geometry, based on the distance understanding. So you can get the solution is this one. Second solution is exactly like what are we doing? All right. There's two possible situations. if I say x greater or equal than 0, if let x greater than 0, the absolute x can be taken away the absolute, right? This absolute x can be taken away because x is positive number, we take it away less than 1. So you can see what this means. This means x greater or equal than 0 and less than 1. What about inside is a negative number? So when you take it about the absolute value, this one get rid of the absolute, became negative x, right? Because of x is a negative number, absolute value became their opposite. So this one is opposite. Totally will be absolute, less than 1. Totally will be positive number, less than 1. All right, so combine these two. So it's x less than 0. What about this one? Both sides divided -1. So x greater than -1. So this one actually is say greater than -1, less than 0. So when you graphing this one, when you graphing this together, you can see graph this part is negative, positive infinity, here is negative infinity, here is 1, I'm sorry, here 0, here -1, here's 1. See this one, here is less greater than and equal than 0 and less than 1, should be between here. What about this part? Less than 0 and greater than -1 should be this part. So all of them plus together here. So x actually less than 1, greater than -1, right? Right? So that's the solution come from. It's the same as the previously. So that's why we summarize like this. Summarize. So whenever I give you x less than a, this a is supposed is a positive number, should be a positive number. So x, you can get a solution is less than a, greater than -a. This one, keep this in your mind. This is what very critical for today's topic. If someone give you an absolute x equal less than a, you can quickly get this step. This actually come from here, right? All right. So let's see the second example. Right now, absolute is inside here. We consider this is a big unit, a big unknown things. All right. So these big unknown things should be less than 3, greater than -3. You just consider this a big A, big unknown things. Absolute value less than 3. So based on this equation, this formula, we can get here. We can get this step, one step to get here. So right now we build actually compound inequality, right? This compound equality, we do the left, middle, and right, 3 steps, right? So first step, with both of them times 3 of them times 3, times 3, times 3, left, middle, left, and right, do the same step. So here became 1, right? So became 2x minus 5 less than 9, greater than -9. 3 side plus 5, plus 5, plus 5. So here is left -2x. Here it became 14. Here it became -4. All right. The third step, all of them divide -2, divide -2, divide -2. So -2 is a what? A negative number. We need to change alligator mouse to a different direction, right? All right. Let me erase partially of this stuff here. Okay, so what do you got here? So here it became x, right? Here it became 2. Here it became -7. So that's the solution for this one. We can get it here or here, get it here. So use the 1 step, 2 step, 3 step, 4 step. All right. Okay. All right. Let me see if I have additional example need to be talked. I think we pretty much, let's leave this one for homework. Okay, for the homework. All right, let me talk one of them. Talk one of them before we end today's talk. Okay, like this one. Let's pick one. Pick last one. Okay, pick last one. Let me quickly go pick last one and then finish today's topic. Pick the 22. Like this one. What do we need to do like this one? Containing absolute value. When we to do this one. Firstly, we want to keep this one in one side. So we want to move the 8 to the right side. So both sides minus 8. All right. So you can get 4v minus 7 absolute value greater equal than right. So we need two situations, right? We need to judge this part. We want to say this one possibly is greater equal than 0, or this part may be less than 0. They possibly, right? Will a positive number or 0? So when there is positive number, we get rid of this absolute. We find this part, right? When they are negative number, we needed to put a negative in front of here and less than greater or equal than 9, right? Right? If they are inside is negative, when you get absolute, you need to add negative in front, and the rest was not changing. We build these two compound. Build these two what? Two compound inequality, right? So what do you got? So actually this one greater or equal than 0, and this one also greater than 9. So definitely combine these two will be 4v minus 7. Actually this need greater than 9. The greater than equal than 0 and then greater equal than 9, that should be greater equal than 9, right? Right, so both sides plus 7. So 4v plus equal than 16. So v greater equal than 4. So you got this one for the left part. For the right part, we do a proper changing first. So move this one to the right. This one became both sides times -1. And alligator mass changing, right? So became 4v minus 7 less than equal -9. See, so it's 4v minus 7 less than 0. 4v minus 7 less than -9. Okay, so combine these two. So we got this one 4v minus 7 equal or less than -9, right? So we do the proper transform as well here, right? So both sides plus 7. So you got a 4v less than equal -2. So both sides divided 4 less than equal -half. So your solution actually is v should be greater than 4 or greater equal than 4 or less than half. So actually have two parts, two solutions, right? So let's graph in here. One is 4 and filled, then this part is this area. The second one is -half is right here, middle of them, -half, including and this part. So when you write interval notations, will be -infinity, -half. I'm sorry, upstairs. But and 4, this use the bracket, right? Bracket because of they are equal to positive infinity. All right, I think we over time a little bit today. We talk pretty deep part about absolute equations, equation containing absolute value and complex inequality. That's a little bit not easy, so quick to understand, but very helpful information, especially go to Algebra 2, they will teach you more. And that's all for today. I think I will send out homework later. If you have any questions, and welcome to call me or ask your parents as well anytime to contact me, send me, take a picture of your question, send to my WeChat, and I try to answer and write down and send picture back to you. Or maybe we can set up small kinds of meeting through Zoom or WeChat. We talk about discussion about that. Sounds good. That's all for today. Thank you so much.
Thank you. Bye.
Thank you.
See you
Bye.
later.
Bye.
Week.